Hello folks, we are now with a new chapter number 13. This is limits and derivatives, very important from next year's point of view. So we are going to take up problems from this. There are 3-4 methods by which we do the limit. Either it is by substitution, or it is by a formula, or it is trigonometric, depending upon the type. So as the type comes, we will solve it accordingly. So let's start right away. This is our exercise 13.1 and it's a part 1 video. The first question says that you should find the limit as x tends to 3x plus 3. X is tending to 3 means x is very close to 3. In such case, what is the value of x plus 3? So x is very close to 3 means it's almost 3. So you are allowed to substitute the value as 3. So what will come here? It will be 3 plus 3. We are allowed to substitute instead of x 3. So 3 plus 3, the answer is 6. That is the method of substitution. Similarly here we see that x is tending to pi, very close to pi, not pi but very close to pi. So you are allowed to substitute the value of pi. So you will get pi minus 27. If you wish, you can substitute pi as 22 by 7. Then it is 22 by 7 minus 22 by 7. Answer is 0. That way also you can do it. Limit as r tends to 1 pi r squared. So you can substitute the value of r as 1. So 1 squared. So that is pi into 1. The value is pi itself. Value becomes pi. Then you have limit as x tends to 4. These are all going with substitution. Tending to 4 means takes the value 4. Very close to 4, so it can take the value 4. So it's like 4 times 4 plus 3 and 4 minus 2. That means 16 plus 3 by 2. That means 19 by 2. Yes, that's the answer. Next, limit as x tends to minus 1, very close to minus 1. So it's like minus 1 raised to 10, minus 1 raised to 5, plus 1, minus 1, minus 1. So it's like 1. And this is like minus 1. This is 1. Minus 1, it's 2. So it's 1 by minus 2 or minus half. That's the problem number 5. Then you have the problem number 6, which says that limit as x tends to 0, x plus 1 raised to 5 minus 1 by x. Now the technical problem over here is, if we go for substitution, then the denominator becomes 0 and the whole expression becomes meaningless. So in such cases, substitution won't work and you'll have to take some other strategy. As I said, there's a formula for this that we use in certain cases, that is limit as x tends to a, x raised to n minus a raised to n by x minus a. Suppose if you have an expression of this form, then you have a ready-made formula by which you get the answer, and the ready-made formula is n a raised to n minus 1. N comes from here, a comes from here. So that's how you get the, and that is what we are going to use here, because it is almost of that form. So let's do one thing. In order to get it in this form, we'll do a small substitution. Let u be x plus 1. Yeah, let us see how that is going to help us. They say that as x tends to 0, what will happen to u? Means x is 0 actually. 0 plus 1, u goes to 1. Let's convert the whole expression. Let's convert the whole expression in terms of u. So given becomes limit as u tends to 1. We have called this as u. So this is u raised to 5. 1 and 1 raised to 5 is 1 and the same. There's no harm. You can 1 raised to 5, 1 is the same. And denominator, it is x. You can see from here that x, if you take the 1 on the other side, it becomes u minus 1. So we call it like this. Right, instead of x, you cannot have one expression in both the variables x and u. That's not allowed. Either you work with x or you work with u. So we are converting everything in terms of u so that we get it in standard form, because the x thing, it was not in standard form. We want to get it in this form. So we have got it converted. Now we are getting it into this form, and once you get it in this form, it's very clear to us that the answer is n a raised to n minus 1. N for us is 5, a for us is 1, n minus 1 means 5 minus 1 is 4. So 5 into 1 or whatever, answer is 5. That's your answer. Right. So you get the answer as 5. Now let's see, next one also substitution is difficult, because 2 squared 4, 4 minus 4 will become 0. But most of the cases, if you have polynomial in the numerator and denominator, generally factorization works. So you can factorize numerator and denominator. Probably certain things will cancel and you will be able to get your answers. Let's see how it is. Limit as x tends to 2. Let's factorize this. 10 into 3, it's 30. And what is that factor of 30 which will give minus 1? 6 and 5 I think should work. Yeah, let's have 6 and 5. 3x squared minus 6x plus 5x minus 10 in the numerator, and this is of course of the type a squared minus b squared. So it breaks as a minus b into a plus b. Also in the numerator you will have 3x common, x minus 2, and 5 common, x minus 2. So like in the next you could have it factorized. So you could have limit as x tends to 2, 3x plus 5 times x minus 2 and x minus 2 and x plus 2 here. So the x minus 2's can cancel and x minus 2 is a culprit. That is where if you substitute 2 it becomes problematic. So that's gone now. Now you can go in for a substitution. So what you'll get 3 times maybe 3 times 2 plus 5 and 2 plus 2. So that's 6 plus 5, 11 by 4. That's your answer, 11 by 4. It's worth cross checking. Yeah, 11 by 4, that's correct. That's about the problem number 7. Now let's take the problem number 8. See what does it say? It says that it's x raised to 4. Again same problem. You substitute this. 3 3s are 9, 9 2s are 18. And then 18 minus 15 minus 3. Denominator is becoming 0. So we are not allowed substitution. Polynomials generally we will have to go in for factorization. So this will break as x squared minus 9, because this is actually 3 raised to 4 basically. So it's like 3 squared and x squared plus 3 squared. That's how we go for factorizations. This is 3 2s are 6. And you have to get minus 5. So minus 2 minus 3 I think should be okay. Minus 2x minus 3x minus 3. Let's further factorize this could be x minus 3 into x plus 3. And this will become x squared plus 9. And here now this is 2x into x minus 1 and 3 into, then that is not a problem, that is not correct. So if you have 6, so minus 6x, yeah, I think there is a sign problem, so minus 6x plus 1 should be okay. Let's check. Minus 6x plus x, so it is 2x out, x minus 3, yeah, this is what is going to work, plus 1 time x minus 3. So limit as x tends to 3, what all things we have? X minus 3, x plus 3, x squared plus 9, x minus 3 and 2x plus 1. Now here the culprit is this x minus 3 that's getting cancelled. The later terms you can substitute and find out. So it is like when you substitute it's like 3 plus 3, it's like 3 squared plus 9, and this is like 2 into 3 plus 1. How much does it come to? 6. 9 plus 9, 18, 7. So 6 8s are 48, 4 carry 108 by 7. It doesn't simplify, it will come to 108 by 7. So that's about, oh, why did I rush so much? I thought that there is some other problem and there's no place and things like that. This is, maybe I'll write a little more elaborately. It's like 3 plus 3 times 3 squared plus 9, 2 into 3 plus 1. So that's 9 into 18 by 7 I suppose. Yeah, so that was 108. Oh sorry, this was 6. 6 8s are 48, 4, yeah, 108 by 7. That's the answer. So we have 8 problems solved, though they were very simple, just substitution problems. In the next video we will be taking up the remaining lot of problems. Thank you.